I ride my bicycle for 30 miles. If I tell you where my position is as a function of time, can I give you that function?
MIT scientist Dr. Daniel Kabat.
I'll write what position was as a function of time. So P of t, g divided by 3t squared. That's my position function. What you gotta tell me is, did I break the law? Can you use math to tell me that?
Yeah.
How do you do it?
Yeah, we don't we'll use that function later in the math.
Okay.
First you draw a diagram. Remember, you need all diagrams to solve all math problems. If you had no diagram, you wouldn't be able to find out how you would solve this.
But that's right, diagrams are good.
I mean, it's at rest, then the initial must always be 0, or t in it. So this is your bike. I don't usually know how to draw a bike right now, so I'll just draw a skateboard.
Okay, a skateboard is fine. I like to skateboard too.
So D1, there's nothing because let's make this longer. So D1 we don't know, and T1 is equal to 1. How would that even be possible? So in D2, as you said, there was the speed limit sign, 25 mph. That stands for mile per hour, and D2 equals to 20. T2 is equal to, we don't know, and at the final, let's just draw a flag. So that means that the final equals to, we don't know, and T final is equal to 3 over 2, otherwise known as 1.5. Do the graph. You always need space for the points to intersect. So this time we're gonna use only 3 spaces. 1, 2, 3. This is 0.5. This is 1, 2, 3. This is 1 and 1, 2, 3. This is 1.5.
Okay.
So, and this is the origin. It's not just for the numbers. It's also for the parabola and the other stuff. So, whoops. So 1, 2, 3. This is 10. 1, 2, 3. This is 20. And 1, 2, 3. This is 30. They'll probably intersect on the line some way. Whoops, the parabola and the line have to intersect here. So let's erase this parabola and let's try this again. No. Yep, and the line. See how they intersect at this point? That's we have to find the velocity of the line at that case. So we'll do that after we find df. As we know, it's still missing. So the final, we actually use P of t equals to 3 over 3t squared. But if you already know the time, you just need to use this. 40 over 3t squared. So now we get 40 over 3, 3 over 2 squared. So if you do the math, 3 times 3 equals 9 in the 3 multiplications table. And 2 times 2 equals 4 in the 2 multiplications table. So let's copy those answers down. So 40 over 3 times 9 over 4. So 4 goes to 40 10 times. I gotta push my chair in if I want to sit. So that 10 times 3 and the result gives you 30. So this must be 30.
Very good.
Now let's erase this stuff. I'm a lot older now, but that's why I know this problem so much. So T2, oh wait, we're doing this. So the velocity is df minus di over tf minus ti.
Very good.
So df is 30 and the initial is always 0. So 3/4 of our fraction is done. 30 minus 0 over 3 over 2 minus 0. That leaves us with 30 times. We flip this fraction like this. So 2 goes to the top and 3 goes to the bottom. Let's copy that down. So 2 and 3. So 3 goes to 30 10 times. So that gives us a result of 10 times 2 equals 20 because in the truth table 2 times 10 equals 20.
Very good.
Anyways.
So how do you know if I broke the law or not?
Maybe you could have break the law. We don't know yet. So now let's solve T2 because we know that it's still missing. This time we're doing it backwards. So T2 usually it's actually P of T equals 40 over 3t squared. I'm using P of T because we don't know the time. T2, so it's equal to 1. So no. This whole thingy is replaced with 20. So 20 equals 40 over 3t squared now. Seriously? So now we add 3 over 40, the reverse of 40 over 3 to both sides. 20 it goes to 42 times in the 20 table. 20 times 2 equals 40. And these guys cancel. Even though the t square is still there. So that's not included. So our answer is squared. If it was to be t squared, it will be 3/2 like TF is, but it's actually T2. So it's the square root of 3/2. Which is equal to 12.22.
So, very good.
So this will be 1.22. Otherwise, consider the square root of 3/2. Which is the square root of TF. Or T final, I mean. So let's erase this stuff also. Again, we know the time. So we'll use only 40/3t squared again. So that means the time is 1. And how could that possibly be? So 40/3 1 squared would leave the same result except for the t squared, because the t is replaced by 1. So this is what you got. But if you do the other math, you got 13.33.
Very good.
So D1 you get 13.33.
Excellent.
So T1 equals 1 and D1 equals 13.33, otherwise considered as 40/3. Just add t squared. That's our position function.
Very good.
Oops, forgot to write it here.
Excellent. Very nice graph, by the way.
We'll erase this stuff again. And this one. You see that intersecting? We'll draw a line there. And we have to find the velocity of that line again, since it also cuts on the intersect. So V equals what? So we'll do this and then just the calculus. So D2 minus D1 over T2 minus T1. What you know, D2 is 20 minus D1 is 13.33, otherwise considered as 40/3. But let's just write 13.33 for now. Over T2 is 1.22 as considered square root of 3/2, which is actually square of T final. But let's just write 1.22 for now, minus T1 equals 1. So that gives us 6.74. I don't know the rest of that. It might sound like pi or something. And 1.22 minus 1, which is 0.22, which is equals to 31 mph.
Oh, is that right?
Yeah. But
Okay.
Wait, no.
Does that sound like I'm breaking the law? I don't know. Now I'm kind of worried.
No, 31 is bigger than 25. if it would have been that pH, you would have broke the law, but it's not that pH.
So I could be in big trouble. I gotta know, did I break the law or not?
It's a little bit close to 31 MPa.
Okay.
Yes, T equals 40 over 3 T squared. Hey, that's our position function. So P prime of T equals to limit as delta T goes to 0. I'm thinking about eating that candy right now.
I am too. Because it looks pretty tasty.
Yeah, it's chocolate. So limit as delta T goes to 0. 40 over 3 parentheses T squared plus delta T whole squared minus 40 over 3 T squared. That's our position function.
Wow, okay.
Over delta T. P prime of T equals limit as delta T goes to 0. So 40 over 3. How did this just get bigger? T squared plus 2T delta T plus delta T squared minus 40 over 3T squared.
Wow.
Wow, that's a very big one.
That's a big formula.
Over delta T. So we'll distribute this stuff.
Okay.
So if we do, that gives us P prime of T. Watch, you'll get an even bigger formula.
Really?
Yeah. Limit as delta T goes to 0. 40 over 3T squared plus 2T plus 80 over 3T delta T plus 40 over 3 delta T squared minus 40 over 3 T squared. I meant to get this parenthesis over delta T. I couldn't have space.
Kind of running out of space.
Yeah. So that can't leaves us canceling out 40 over 3T squared and this one. So prime of T equals limit as delta T goes to 0 plus 40 over the delta T squared over delta T squared. Wait, this is 80 over 3T delta T plus 40 over 3 delta T squared. So
Looks good.
So P prime of T equals to limit as delta T goes to 0. Watch this. Delta T parenthesis 80 over 3T plus 40 over 3 delta T over delta T. Delta T canceled. This is kind of like y equals x squared. So P prime of T equals to 40 over 3 T delta T goes to 0. So the start of the equation kind of gives you a clue. So read what me. This is 80 over 3. This is not the actual answer. because this is just a part of the other formula. Here's the real answer. So here of 1.22 equals to 80 over 3, 1.22.
Uh-huh.
What gives you 32 and P8? You sure did break the law.
Really?
I told you it was close to 31.
Wow.
You really did break the law.
Am I in big trouble?
Yeah.
Uh-oh, I better watch out.